Welcome to Ganita Samayaha, an interactive learning space. Children, during the course of my teaching, whenever I pose in questions, please answer them. This will help you in the learning process. Also, please don't forget to have your writing materials with you whenever you watch these videos. And after you watch, please subscribe, like and share the video. So let's get started now. Children, today we will start learning about triangles and in particular about similarity of triangles. This is part 1. Before we actually get into the subject, let us take a quick recap on what we have learned in the previous classes. Here you can see two squares. When we talk about squares, we know that both of them have got the same shape. But now we are interested to know about their sizes, if they are same or different. So what do? We place them one upon the other and observe them. What do we observe? They are exactly overlapping on each other. So this says that they are of the same size. Good. And these circles? Yes, they too are of the same size. And these stars? They too are of the same size. So we have seen a set of figures that have the same shape and size. Let's see a few more figures now. These two are rectangles. And on observing, we know that they are of different sizes. These two squares are also of different sizes. And these two circles as well. So we have another set of figures that have the same shape but different in size. So collectively, we have seen two sets of figures. One same shape and size, other same shape but different sizes. So what do we call such figures? These figures have same shape but not necessarily same size. They may have the same size or may not have the same size. All these figures are called as similar figures. Okay, children. So what are similar figures? Figures that have the same shape but not necessarily the same size are all said to be similar figures. Now, we have got a few more figures here on the screen. Are they similar? No, not at all. They don't have the same shape at all. You consider a circle and a triangle. They are not of the same shape. So also a hexagon and a rectangle and so on. So the figures that do not have the same shape are not similar figures. Is that clear, children? Okay. Now, considering those figures that have the same shape but may have same size or different size, we know that they are all similar figures. And out of that, in particular, when you consider the figures that have the same shape and size, we all know they have a special name. I'm sure all of you can recall that. What are they known as? Yes, they are all congruent figures. Just now, we have seen that these are all similar as well. So what do we conclude? Yes, all congruent figures are similar. Is the reverse true? Are all similar figures congruent? Not necessary. They need not be congruent. They may be congruent. If they are of the same size, then they are congruent. So, all similar figures are not necessarily congruent, but all congruent figures are necessarily similar. So, this is one point that you all should bear in your mind, children. So, let's proceed further. Here, you can see a set of circles. They're all of varied sizes. Are all of them similar, children? Yes, all circles are similar. They are all of the same shape but different in sizes. What do you see here? Equilateral triangles. What can you say about the similarity of equilateral triangles, children? Yes, they are all similar. All equilateral triangles are similar. They also have the same shape but different sizes. And these are the squares. What can you say about the similarity of squares? Yes, they are all similar. All squares are similar. They all have the same shape but different sizes. So you should remember that all circles, equilateral triangles and squares are all similar in their own respective groups. Fine, children? Now, let us understand what is a condition for any two polygons to be similar. What do you see on the screen? A triangle and a square. Can these two polygons be similar? No, not at all. The reason is they do not have the same number of sides. So, when we have to talk about similarity, we have to consider polygons that have the same number of sides. If they do not have the same number of sides, they cannot be similar and they are not similar, children. Okay? So, two figures with different number of sides cannot be similar. Fine. We have two polygons here. How many sides the two have? Yes, both of them have three sides. Both of them are triangles. So are these two triangles similar, children? Do they have the same shape? Yes, on seeing we can make out that they do not have the same shape. What makes a shape, children? Yes, it is the angles that make the shape. So for the two triangles to have the same shape, they must have same angles. Their corresponding angles must be same for two triangles to be of the same shape. Here I have got two hexagons. We can clearly make out that they are not of the same shape. That is also since their angles are not the same. So, two hexagons can be of the same shape if their corresponding angles are same. So, in general, what can we say, children? In general, two set of polygons can be of same shape if their corresponding angles are same. Only if the corresponding angles are same, you can consider two set of polygons to be of the same shape. Fine. So this is one condition. Is this sufficient or do we have more? Let us explore. So this is the first condition that we have. Two polygons with the same number of sides must have equal angles to be similar. Is this condition sufficient or we need more? We need to explore. Children, you must have seen photographs of yourself and your family members in varied sizes. You would have seen a stamp size photograph, a passport size photograph, an envelope sized photograph, and so on. Just as you see varied size pictures of trees here on the screen. All of them appear to be similar. There is no any distort in the image when you compare one with the other. What has made all these pictures of varied sizes appear to be similar? Let's understand that. Here you can see two pictures, a small one and a bigger one. The bigger one appears to be distorted as compared to the smaller one. They don't look similar. Let us understand why. I place one on the top of the other. What do we observe? The length of the two pictures are the same, but the breadth are not same. The breadth of the bigger picture is elongated, but the length is remaining the same. So this has caused a bit of a distortion in the second figure. Okay, here what do you observe? The second figure is again elongated. Here we have the breadth same, but it is elongated along the length only. Breadth is constant and the length is increased. So this again has created a distortion in the second figure as compared to the first figure. They don't appear to be similar. Now, compare these two pictures. They appear to be similar, though one is big and the other one is small. What is the reason? Let us understand and compare the sizes of the length and the breadth of the two figures, A and P. This is the length of P. When we place it along A, observe what happens. Yes, the length of figure A is twice the length of the figure P. Fine. What about the breadth? Breadth is also twice the figure or that of P. So both the length and the breadth of picture A is twice that of the picture P. That means they have been increased proportionally. It is not that only one side is increased or one side is increased twice and the other side is increased thrice. It's not so. They have been increased proportionally. That means as much as the length is increased, the same amount of breadth is also increased. We have increased the length twice the original and the breadth is also increased twice the original. When you compare P and A, when I compare P with A, what can we say? The length of P is half that of A and the breadth of P is half that of A. So when you are increasing a picture or decreasing a picture, you have to do it proportionally. In the sense, the length and the breadth must be increased or decreased in the same quantity. Okay, so this we call it as increase or decreasing proportionally. Same thing happens when you observe picture P and B. As compared to P, B is 3 times in length and 3 times in breadth. And as compared to P, the picture C is 1.5 times in length and 1.5 times in breadth. So this says that the length and breadth are increased or decreased proportionally. So this gives us the second condition. Two polygons with the same number of sides must have the corresponding sides in the same ratio. So we have two conditions, children. The first condition is all corresponding angles are equal, and the second condition is the corresponding sides are in the same ratio. Ratio is same. They are not same. Corresponding sides are not same. If they were to be same, then they would have been congruent. Of course, congruency also implies similarity. Okay. So what are the conditions for two polygons to be similar? Two polygons of the same number of sides. So same number of sides is mandatory. Otherwise, we don't compare them for similarity at all. Okay. So two polygons, when we say also, it is understood that they are of the same number of sides. They are similar if all the corresponding angles are equal and all the corresponding sides are in the same ratio. So these are the two conditions that we should look for whenever we are asked to find if any two polygons are similar or not. Is it clear, children? Shall we try to explore about finding how the two conditions can be pointed upon or understood in any two quadrilaterals? Yeah. Here we have two quadrilaterals, ABCD and PQRS. So let us try to analyze and understand a few more terminologies and Try to find out whether they are similar or not. If similar, how do we gauge them, or how do we know that they are similar? And if not, why they are not similar is what we are going to understand now. The first condition is the angles must be equal, isn't it, children? So let us look for the angles. See angle A here, it is 105 degrees. And do we have any other angle from the other quadrilateral that is 105? Yes, we have one more angle here from the other quadrilateral which is 105, and that is angle P. So what can we say about angle A and angle P? Angle A is equal to angle P and each of it is 105 degrees. That's fine. So we say angle A and angle P are corresponding angles. The equal angles are known as corresponding angles. Here with respect to two polygons, children, we are not talking about parallel lines. There also we use the word corresponding, but in a different sense. Okay, so here we are concerned with two different quadrilaterals, and when you find two angles equal, those two angles are said to be corresponding angles. As such, here A and P are corresponding angles. And how do we denote them? We needn't have to write in words corresponding angles. We have a symbol. This is how it is written. Okay, we write an equal to sign with an arrowhead at both the ends. This is the symbol for corresponding. Okay, so this is written as A is corresponding to P. Since angle A is equal to angle P, we have angle A corresponding to angle P. Now, similarly, we have angle B equal to 100 degrees and angle Q equal to 100 degrees. So, we have angle B corresponding to angle Q. And so on. We have angle C equal to angle R. So, C and R are corresponding angles. Similarly, we have angle D equal to S. So, D and S are corresponding angles. That is about the corresponding angles. How do we know about the corresponding sides? Observe these two diagrams again. What can you say about the length of side AB and the length of side PQ? What can you say? Yes, we notice that PQ is twice AB. So the ratio of PQ and AB is 2. So also we have a QR which is twice BC, and the ratio of QR to BC is 2. We have QR 5 cm and BC 2.5 cm. Similarly, observe side SR and DC, children. What can you infer? Yes, side SR is twice that of CD. So, the ratio RS by CD is 2, and then the remaining side. Also, we can see that SP is 2 times DA. So, the ratio of SP and DA is also 2. Okay. So, wherever the corresponding sides, the ratio is same, we denote it as PQ is corresponding to AB. This is how it is written. Okay. Side PQ corresponding to side AB, side QR corresponding to side BC, side RS corresponding to side CD, and side SP corresponding to side DA. So this is how we have understood how to identify the corresponding angles and sides when their measurements are given. Okay. So this says that the two conditions are satisfied. The first condition is all the angles are equal, that is the corresponding angles are equal and the corresponding sides are proportional. Okay, so what can you say about the similarity of these two quadrilaterals? The two quadrilaterals are similar. Have you all understood this, children? So whenever we want to talk about similarity, we have to observe the angles if all the corresponding angles are same, and then we have to observe the measurements of both the quadrilaterals and see if they are proportional. If these two conditions are satisfied, then we can say that the two quadrilaterals are similar. Even if one condition fails, then they are not similar. So let us see such a condition further. Here we have two quadrilaterals ABCD and PQRS. When you observe the sides of ABCD each are 2.1 centimeter and that for PQRS each is 4.2 centimeter. So they are proportional. One condition is satisfied. What about the other one? This appears to be 90 degrees. Isn't it, children? In the case of quadrilateral ABCD, all the angles appear to be 90 degrees. So this must be a square. And what about this quadrilateral PQRS? Is it 90 degrees? No, it is not 90 degrees. So though the sides are proportional, angles are not same. Even if one condition fails, then it is not similar. Both the condition must be satisfied for two polygons to be similar. So the two quadrilaterals are not similar since the corresponding angles of the two quadrilaterals are not equal, though the corresponding sides are proportional. Is it clear, children? Let us see another case. Here we have got some exercise for you, children. Say true or false. All squares are not similar. Is it true or false? We just learned them in the beginning of today's class. Yes, false. They're all true. All squares are similar. It's this statement that they are not similar is false. All isosceles triangles are not similar. True. All isosceles triangles are not similar. A square and a rhombus with corresponding sides in same ratio are similar. Just now we saw an example there. Were they similar? No. So it is a false statement. A square and a rectangle are similar. Yes, again false. I hope all of you got these answers right, children. Give two different examples of pair of similar figures and non-similar figures. Similar figures, we have already seen a few. What are they? Circles, equilateral triangles, squares. We also have these right-angled isosceles triangles. Right-angled isosceles triangle will have one angle 90 degrees and the other two angle 45 degrees. So all such triangles will be similar, children. Non-similar figures, there are many. I have cited a few here. Rectangle and square, triangle and circle, isosceles triangle, etc. Okay, fine. Yes, here we have another set of question here. Observe these two quadrilaterals and say whether they are similar or not. Yes, here again we have got the sides proportional but the angles are not the same. So though these two quadrilaterals have their sides proportional, since the angles are not same, they are not similar. Here we have got a case of a quadrilateral ABCD is similar to another quadrilateral PQRS, children. And this PQRS is in turn similar to another quadrilateral EFGH. So what can you say about the similarity about these two triangles, about these two quadrilaterals ABCD and EFGH? Let us discuss. So we have quadrilateral ABCD is similar to quadrilateral EFGH. And every time again, you needn't have to write this. We have got a symbol for similarity as well, children. Either you can write three vertical knives or just this symbol. So this stands for similarity. So we have quadrilateral ABCD similar to PQRS and PQRS in turn similar to quadrilateral EFGH. So what happens to ABCD? Yes, it must be similar to EFGH. That shows that all of them have the same shape but may or may not have the same size. So quadrilateral ABCD must be similar to quadrilateral EFGH. So what did we learn today, children? We have learned that congruent figures are similar and all similar figures are not necessarily congruent. And then we learnt about two conditions for a polygon to be similar, for two polygons to be similar. They are the corresponding angles of the two polygons are equal and the corresponding sides of the two polygons are proportional. So please revise whatever has been done. You can play the video again and again. And if you have any doubts, please put them into the comment boxes. I will reply to them as soon as possible. And please don't forget to subscribe, like and share. Thank you for watching this video. Meet you soon with the second part.